Good. Okay. First experiment is conductometric estimation of an acid using standard sodium hydroxide solution. This experiment we will be performing with the help of an instrument. The name of the instrument is conductivity meter. Conductivity meter. Why we are using instrumental methods for chemical analysis? Why can't we directly do volumetry or gravimetry or complexometry without the help of instruments? There are some issues associated with the conventional chemical analysis techniques such as volumetry or gravimetry. All of you have performed titration in your PUC. Am I right?
Yes, sir.
Yes, sir.
Average time that you took to perform one experiment in the laboratory, one titration in the laboratory took almost 1.5 hours minimum.
Yes,
Minimum
sir.
1.5 hours. See, that means you are investing minimum 1.5 hours, 90 minutes of your time to just study concentration of a sample. 90 minutes to study concentration of a sample. So if you are working in a lab for 8 hours, hardly you can perform 4 experiments or 4 titration. Am I right?
Yes,
Yes,
sir.
4
sir.
titration. You can perform only 4 titration in a day. Last time I visited Karnataka Pollution Control Board. So Karnataka Pollution Control Board collects water sample from different locations of Karnataka, and they brought all those samples into their lab and they will do chemical analysis. And I asked them how many samples that you are getting every day. They said 4,000. Minimum 4,000 samples were collected in a day. Imagine, in order to perform that 4,000 chemical analysis, if they were doing titration, how many employees that they have to recruit? 1,000 employees for a single test? Right? Is it
Yes,
possible?
sir.
Is it possible
No,
to
sir.
recruit 1,000 people
No,
for
sir.
performing a chemical analysis? So the major
No, sir.
issue with the conventional volumetric analysis, first issue, time. It's highly time taking, and time means money. Time means money. If you are spending more time, means you are actually wasting money. Second, effort of a human being. For example, you people are going to become engineer. After that, you are getting a job somewhere, right? 1 hour of your working time is so precious to you as well as for your company. So you are doing only 4 experiments per day and company is paying you a very good amount. Company cannot use that. And you will also get bored. I am just doing only 3 titration per day. What I am doing? I'm not doing any productive things. So issues associated with the conventional wet analysis is time and effort. Time and effort is more. Second point. All of you have performed volumetric analysis. You identified the end point with the help of an indicator by noticing the color change. Am I right? All experiments, all
Yes, sir.
titration experiment that you have performed, you have added an indicator and you check when the color changed. Then you got your end point. Then you used that old famous equation N1V1 equal to N2V2 and you found the concentration of the solution that you got. Am I right?
Yes, sir.
So your performance is based on how can you identify the color change. Am I right?
Yes, sir.
Yes, sir.
Now, if you are color blinded, can you do volumetric analysis?
No.
No, sir.
Because if you are
No,
color
sir.
blinded, you will not be able to distinguish colors. So if color change is like pink to orange, pink to orange. If the color change is pink to orange, a color blinded person may not be able to identify the color change and he will fail in that experiment. It doesn't mean that he doesn't understood how to perform that experiment. Because of his physical status, he couldn't perform that experiment accurately. Next, if you have a Parkinson disease where your hands are shivering, some people, you know that, right? It's a medical condition. Hands will shiver. They will not be able to put anything in hand very firmly. Their hands always will shiver. Can they perform a volumetric analysis?
No, sir.
No. So in volumetric analysis, there is a chance of personal error. Personal error means the error generated by the person who did the experiment. Very important. So can I tell a student or an employee who are color blinded, you know, you are stupid, you don't know how to do this experiment. Then I will be cruel, right? What I'm doing is not the right thing. It's not his mistake that he got color blindness. And now I am judging him based on how he performed volumetric analysis. That guy might be knowing the entire chemistry of that experiment, but he couldn't perform the experiment properly because he's having some issues, right? It's not his fault. It's not his fault. So if I judge that person based on the performance that he can do by observing the color, by holding the pipette properly, by holding the burette properly, that is actually I'm not checking how knowledgeable he is. It's very difficult to assess that person's capability. It's beyond his limit. He is making some mistake. So I should make. So I cannot tell him to go and perform a volumetric analysis. So because there is a chance of personal error, I have to avoid that personal error. For that, I have to use instruments. So instruments, if you do, you can actually avoid all these issues. How? Instrument will identify the endpoint, not you. Instrument will identify the endpoint, not you. So if you have the inability to understand the color change, doesn't matter. Instrument is doing that. Understood?
Yes, sir.
Same thing, and the time that you require to perform an analysis using an instrument is much lower compared to volumetric analysis. I will give you an example. You can estimate concentration of an acid or an alkali using a simple acid-base titration that you have performed in your PUC lab. Minimum 1.5 hours you will have to spend to get the result. But the same experiment, determination of the concentration of an acid or an alkali, that you can perform with an instrument known as conductivity meter that we are going to study now. You can perform that experiment in 20 minutes. You can perform that experiment in 20 minutes. And if you are color blinded, no problem. No problem. If your samples are colored samples, no problem. If your samples are not clear solution, no issue. Conductivity meter will perform that experiment. If your solution is not clear, if your solution is having already color, if the person is doing that experiment who is color blinded, no issue. And the experiment will be done in 20 minutes. So now you understood what are the advantages of instrumental methods of analysis over conventional chemical analysis techniques. Understood? Any doubt?
No, sir.
Okay, first experiment. Experiment number 1, conductometric estimation. Conductometric estimation. Title: Conductometric estimation of an acid using standard sodium hydroxide solution. First, I will explain what is title. What is the objective of our experiment? Our job is to estimation of an acid. Estimation of an acid means find the concentration of an acid. Okay, find the concentration of an acid. For that experiment, a standard sodium hydroxide solution will be given to you. Standard sodium hydroxide solution means sodium hydroxide solution with a known concentration. So I will give you sodium hydroxide solution and I will tell you what is the concentration of this sodium hydroxide solution. Using that sodium hydroxide solution, you have to find the concentration of an acid. This experiment you have performed in your PUC. Am I right?
Yes, sir.
But at that time, you were using an indicator which was phenolphthalein. Am I right?
Yes, sir.
But here, I will not be providing you any indicator. So you are not finding the concentration of an acid with the help of an indicator and checking the color change. No. Instead of that, I will provide you one conductivity meter. One conductivity meter I will provide to you. Using that conductivity meter, you have to find the concentration of an acid. Understood the question now? Any doubt?
No, sir.
No. All of you know that how to calculate concentration of an acid if concentration of an alkali is given to you, N1V1 equal to N2V2. Any doubt in this equation? All of you have done this experiment?
Yes, sir.
Right? So we are going to use this equation to perform or to calculate the concentration of an acid. Which acid I will provide? I will provide you dilute hydrochloric acid solution I will provide. Dilute hydrochloric acid I will provide. This dilute hydrochloric acid is a strong acid. Strong means, doesn't mean that strong means corrosive in nature. No, strong means if you dissolve that acid in water, it will dissociate completely. That is a strong acid. If you take hydrogen chloride and you dissolve it in water, you will get hydrochloric acid, where the entire hydrogen chloride molecules are dissociated into H plus ions and Cl minus ion. If complete dissociation occurs for an acid in an aqueous solution, we call that acid as strong acid. So hydrochloric acid is a strong acid. Understood?
Yes.
Our job is to find its concentration. I will provide you sodium hydroxide solution with a known concentration. We will give you sodium hydroxide solution of having a concentration of 0.4 normal concentration. Then you have to perform that experiment. Then use this equation. Then you can calculate what is the concentration of HCl. I told you I am not going to provide you any indicator. I'm not going to provide you any phenolphthalein or methyl orange or any type of indicator for this experiment. You have to find the end point or equivalence point using a conductivity meter. So this is the small, very simple experiment, very simple setup. I'm going to discuss you about the instrumentation of this instrument. Conductivity meter. So what it will measure? As the name suggests, it's a conductivity meter. Meter means measurement. Conductivity meter means measurement of conductivity. So we will be measuring conductivity. What is conductivity? That I will define later. Very simple instrument. This instrument is having two different parts. One, a display and a control unit. Another one, a conductivity cell. So conductivity cell is like this cylindrical type of apparatus, and this is a display and control or processing unit. As the name suggests, this is a cell, conductivity cell, not galvanic cell. Don't think about it is like a galvanic cell. No, this is a conductivity cell. Cell means how many electrodes will be there for a cell? How many electrodes should be there in a cell?
2 electrodes.
Two electrodes. But you can see only one rod which is dipped in the solution.
Yes,
Yes,
sir.
sir.
But at the end, at the tip of that rod, there are, I don't know whether is it visible, two black dots. Can you see two black plates? Very carefully, if you observe, you will be able to see.
No, sir.
Okay, once I will give that full representation of a conductivity cell. At that time, you will understand. There are two very small platinum foils. Students are joining. There are two small black platinum foils are at the tip of that rod. So two electrodes. These platinum foils are electrodes. So two electrodes form one cell. So this conductivity cell, at the tip of the conductivity cell, there are two electrodes made up of black platinum. Why we are using black platinum? Why we are not using the white platinum? That I will discuss later. There are two black platinum foil at the tip of this rod, and these two electrodes makes the conductivity cell. Understood? Any doubt?
No, sir.
Now, our job is to measure conductivity. After measuring the conductivity, we have to find the concentration of the acid. So, which solution's conductivity you have to measure, that solution you have to take it in a 100 ml beaker. You can see a solution in it. So you have to take the solution. Solution here it is hydrochloric acid, right? Our job is to find the concentration of hydrochloric acid. So that hydrochloric acid, you have to take it in this conductivity, this beaker. Generally, we will take 25 ml of hydrochloric acid, and that 25 ml of hydrochloric acid, we will put it in this 100 ml beaker. Then into that beaker, we will dip the conductivity cell. So what this conductivity cell will do? This conductivity cell will measure the conductivity of this solution, and that conductivity value will be displayed in this display unit. Got my point?
Yes, sir.
Yes, sir.
So which solution's conductivity you wanted to know? Just put conductivity cell into that, switch on the machine, the measurement you will get. Simple, very simple. So measurement of conductivity is not a big task. By just putting the conductivity cell in the solution, you will be able to get what is the conductivity of that solution. Now, going back to the theory. This conductivity cell, what it will measure? Conductivity it will measure. Now question, what is conductivity? How you will define conductivity?
Flow of electrons.
Conductivity. Flow of electrons is electrical current. Conductivity. Conductivity, all of you know that it is reciprocal of resistivity. That you studied.
Yes, sir.
But is it a definition? Conductivity. One person is asking what is conductivity. So we are telling it's the reciprocal of resistivity. But that didn't communicate any meaning. It's like one person is asking to you, I wanted to go to north, what I should do. So you are telling you just travel opposite to the north. Whether any meaning is communicated to that person? Nothing. If one person is asking where is south, you are telling it's opposite of north. He will not understand anything, right? It's just, if he wants to go to the south, you should point him, this is the south. This direction you have to move. If you are telling it's just opposite of north, that is just a statement. That person is not going, still he is not going to understand where is south and where is north. If he understood where is north, then he doesn't have to ask to you which is south. Am I right?
Yes, sir.
Yes,
So
sir.
definition, like what is conductivity, if somebody is asking, it's a reciprocal of resistivity. Then the next question comes, what is resistivity? Then you have to explain what is resistivity. Then that resistivity you have to take and take the reciprocal. Then you will get conductivity. That is not the right way. So there will be a definite definition for conductivity that we have to study, because we are going to measure conductivity. If you are measuring conductivity, you should know what is conductivity. Two words, conductance and conductivity. Both these words you have studied. I'm sure that you have studied both these words in electrochemistry in PUC. Are they same? Conductance and conductivity, are they same?
No, sir.
No, sir.
They are different. They are different. So first we will study what is conductance. Conductance is ease of flow of ions in a solution. How easily the ions move through a solution. That is known as conductance. Clear?
Yes, sir.
Yes, sir.
How easily ions will move through the solution. That is conductance. Some solutions will have more conductance. For example, a solution contains higher number of H plus ions. We know that H plus ions means that is the smallest ions, right? Smallest ion, H plus ion. Because they are very small, they can move very fast. So the solutions contains higher number of H plus ions always shows higher conductance. Understood?
Yes, sir.
Same time, you are taking a bigger ion. For example, lead ion. Lead ion. Lead is a very big atom, and its ion is also very big. So if a solution contains lead ions, whether that solution will have the same conductance as that of a solution contains H plus ions?
No, sir.
No. So conductance of a solution is the measure of how easily the ions will flow through a solution. Got my point? Any doubt?
No, sir.
No doubt. Conductance, normally we will use the letter C to represent, and its unit is, Simon, is S. All of you study. SI unit of conductance is Simon. Normally we will represent using S. Now we can ask a question. Conductance now we defined. Next is how to define conductivity. Little bit difficult to understand what is conductivity. For that, I will take one example. Instead of flow of ions, to make you people understand, we will discuss about flow of water. So whenever I say water, you should mean that is ion. Okay? Water means ion. So I will give an example based on water. So whenever I say water, you should listen it as ions. Okay? There are two pipes, cylindrical pipes, A and B. Both are having same length, but having different cross-sectional area. B is having more cross-sectional area. Two pipes, A and B, both are having the same length, but B is having more cross-sectional area compared to A. Now I am asking you a question. I want to pass water through both the pipes. Which pipe will give maximum output of water at short time? Pipe A or pipe B?
B.
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 Reason? More water can flow through B because of its higher cross-sectional area. So now, more water flow means more ions flow. More ions flow means conductance. Am I right?
Yes, sir.
So can I write conductance is directly proportional to area of cross-section?
Yes, sir.
Because cross-sectional area increases, conductance increases. So for a solution, if the cross-sectional area of the solution increases, conductance of the solution also increases. Any doubt?
No, sir.
Now I have another two pipes. One red pipe. Next, what is this color? Violet. Both the pipes. They are having same cross-sectional area but different lengths. I want to pass water through both the pipes. Which pipe will give maximum output of water at short time? In short time. Which one?
The upper one.
Red or violet? These two. Red or violet?
Red.
Red.
Right.
Red.
Reason. Violet, it's a long pipe, right? This violet is a long pipe. So water will take
It takes
more
more
time to
time.
flow, right? So output will be more for the pipe which is having less length. So can I write now conductance is inversely proportional to length of the solution?
Yes, sir.
Got my point? Now I am combining these two equations. C directly proportional to A, C directly proportional to 1 by L, or C inversely proportional to L. I am combining that. So can I write like this? C directly proportional to A by L. I combined equation. These two
Yes, sir.
equations I combined and I got this one. Normally, if you want to remove directly proportional sign into equal sign, what you should do?
Introduce a
Use a
constant.
Yeah, you
constant.
have to multiply it with a constant, right? So here I gave a constant kappa, Greek letter kappa, not K. This kappa is conductivity. Got my point? Our objective was
Yes,
to
sir.
define conductivity, right? So this is conductivity. Another word, another name for conductivity is specific conductance. Both are same. Specific conductance and conductivity both are same. But still, we have not defined specific conductance, right? We got an equation where specific conductance or conductivity is present. Still, we have not defined. Am I right? We have not
Sir.
defined it, right? To define what I am doing, I am bringing this A by L term to the opposite side. So I will get an equation for now conductivity. I will get an equation for conductivity as conductance into L by A, right? Conductance into L by A. Can I write like this equation now? Did I get an equation for conductivity now?
Yes, sir.
Now, this L by A, we call it as cell constant. You heard about this cell constant, right? In electrochemistry, you studied about cell constant, the same cell constant. So L by A, we call it as cell constant. This will be same for a particular electrode. So if you come to the lab, you take a conductivity cell. That conductivity cell is having a constant, the same cell constant every time. Monday you come, you do. If you are taking the same conductivity meter, the L by A value will be a particular value. If you are coming next year also, if you are taking the same conductivity meter, L by A value will be same. So L by A, that's why it is known as cell constant. No change, cell constant. Okay. imagine the cell constant is 1. Imagine the cell constant is 1. Cell constant 1 means length of the solution 1, area of the cross section 1, then L by A will become 1. Am I right?
Yes, sir.
Then if cell constant is 1, then kappa will become conductance. Conductivity becomes conductance. Right. When L by A equal to 1, conductivity equals conductance. Right?
Yes, sir.
Now I am going to define now conductivity. Conductivity, which is kappa, is the conductance offered by a solution of unit length and unit area of cross section. Or conductivity of a solution is the conductance offered by a solution of having cell constant 1. Right?
Yes, sir.
So I gave you the definition of conductivity. Conductivity, that is kappa, is the conductance, which is C, offered by a solution of unit length and unit area of cross section. Got my point?
Yes, sir.
Now you can ask a question to me. Sir, length and area for a solid material, okay, length and area we will be able to. How you will measure length and area of a solution? Question can come, right? How you will calculate the length of a solution? How you will calculate area of a solution? Right? It is a liquid. Liquid length area, normally we don't use that. For liquid, normally we will use to quantify liquid volume like liter, right? Liter, milliliter. But here, I'm talking about length of a solution, area of a solution. This may be confusing, but no problem. Once I will explain you the instrumentation of the conductivity cell, at that time you will understand what this L means, what this A means. Okay?
Yes, sir.
Okay. What we are going to do? I told you, if you want to measure the conductivity of a solution, you have to take that solution in a beaker, definite volume of that solution in a beaker. And inside that beaker, we have to keep the conductivity cell. So our objective is to find the concentration of HCl. So I have taken 25 ml of HCl in a beaker. Can you see that beaker? 25 ml of beaker I have taken. Okay?
Yes,
Understood?
sir.
Okay. Now I told you HCl is a strong acid. The entire HCl molecules will be splitted into hydrogen ion and chloride ion. Does it mean that any unbroken HCl is present in the solution? Any unbroken HCl as a molecule? Nothing will be there. Whatever HCl you are adding into the solution, that solution will contain only H plus ions and Cl minus ion. Got my point? Any doubt?
No, sir.
Clear?
Yes, sir.
Now, this solution contains now ions, right? H plus and Cl minus ions, right? Ions are the reason behind conductivity. If there is no ion in a solution, that solution will not have conductivity. Definitely, hydrochloric acid solution has conductivity because it contains a good number of H plus ions and Cl minus ion. So due to the presence of a good number of H plus and Cl minus ion, this solution will have a very high conductivity. Any doubt?
No, sir.
No, sir.
Okay. To measure that conductivity of that HCl solution, I have to dip the conductivity cell. So this is the representation of the conductivity cell. This one, I dip conductivity meter, conductivity cell inside the solution. Now, can you see now the representation of two platinum foils? black at the tip of the conductivity cell. These are the electrodes
Yes, sir.
made up of platinum. These are the electrodes made up of platinum. Now, my question, are they touching each other or they are separated by a distance? These electrodes, are they touching each other
Separated.
or they are
No, sir,
separated
they
by
are
a
separated.
distance, right?
Separated by distance.
That distance is filled with the solution. That distance between the space between the two electrodes are filled with the solution. Am I right?
Yes, sir.
That solution contains H plus and Cl minus. Right?
Yes,
Yes,
Now,
sir.
now, what these electrodes does, it measure the conductivity of the solution, which are in between the electrodes. So these two electrodes will measure conductivity of the solution which is trapped between these two electrodes. Only that solution conductivity. These electrodes are not measuring conductivity of the entire solution. It measures the conductivity of the solution trapped between the electrodes. But our objective is not to find the conductivity of only this much, right? Our job is to find the conductivity of the entire solution. But this setup will not give you that. This setup will give you the conductivity of the solution which is trapped between the electrodes. Got my point?
Yes, sir.
But which solution is trapped between the electrode? Same solution is there outside, right? Same solution. Nature of the solution is same outside and in between, right?
Yes,
So
sir.
even though you are measuring the conductivity of the solution between the electrode, you are indirectly measuring conductivity of the entire solution. Am I right?
Yes,
If you didn't understand, I will give you an example. I am giving you one bottle of salt water, one bottle or one glass of salt water to you. And I am giving to one of you and I am asking, is it salty or not? This water is salty or not? In order to test whether it is salty or not, whether the student has to drink the entire glass of salt water, is it necessary?
No, sir.
No,
Just
sir.
take
sir.
a
No,
sip.
sir.
Just take a sip. You will understand it is salty, right? No need to drink the entire glass of water to test it as salty. You will not think first sip may be salty, maybe second sip will be sweet. Do you think like that?
No, sir.
No, sir.
So even though the electrodes which will measure the conductivity of the solution which is trapped between these electrodes, it is indirectly measuring the conductivity of the remaining solution. Got my point?
Yes, sir.
Clear? Any doubt? Okay.
No, sir.
Now,
Hmm.
by just putting conductivity cell, we will measure only conductivity, but our job is to find the concentration. Our job is to find the concentration. From just conductivity value, we will not be able to find the concentration. For that, we have to perform the experiment. We have to perform the experiment. How? To this solution of acid, we have to pass sodium hydroxide solution. This concentration is known to you through a burette. Through a burette, we have to add sodium hydroxide solution. Got my point? Any doubt?
No, sir.
No.
No, sir.
Now, before adding sodium hydroxide solution, the beaker was having only hydrochloric acid. Only hydrochloric acid. Am I right? Hydrochloric acid contains a good number of H plus ions and Cl minus ions. Out of these two ions, H plus ions are very small and they can move very fast. So the conductivity of hydrochloric acid solution as such is very high. The conductivity of HCl solution is high due to the presence of a higher number of H plus ions which are having higher mobility because of their small size. Got my point? Any doubt?
No, sir.
Okay, next step, what you should do, next step, add 0.5 ml of sodium hydroxide to this solution. Add 0.5 ml of sodium hydroxide solution into the hydrochloric acid. After adding that 0.5 ml, with the help of a straw, you have to mix the solution properly. Mixing should. So during that mixing, what happens? NaOH that we supplied as 0.5 ml will react with some of the HCl and forms NaCl and water. Am I right? Simple equation. Any doubt in this equation? We know that hydrochloric acid reacts with the sodium hydroxide, forms sodium chloride and water. Clear?
Yes, sir.
Yes, sir.
So no doubt. Here what actually happening? In HCl, there were H plus ions. Am I right?
Yes,
Right?
sir.
That H plus ion now converted into water. What does it mean? H plus ions concentration decreases or increases when you are adding sodium hydroxide? What happens?
Decrease.
Decreases. You can ask, let it decrease, but a new ion that you got, sodium chloride. Sodium chloride, we know that it will dissolve in water. It is a salt. When it dissolves, it will become ion. So H plus is now replaced with the Na plus ion. So the number of ions didn't decrease. Am I right? Number of ions same. Initially it was HCl, now it is NaCl. Both will dissolve in water and will form ions. Initially it was H plus and Cl minus ion, now it is Na plus and Cl minus ion. Number of ions are same, but conductivity will be less. Reason, initially it was having more H plus ions. H plus ions were small, their mobility was high, so they could move fast, conductivity was higher. Now that H plus is converted into water, instead of H plus, a new ion Na plus came, but Na plus are bigger than H plus ion, so their mobilities are less. Am I right? So conductivity will decrease. Am I right? Conductivity will decrease. Any doubt?
No, sir.
So conductivity
sir.
will decrease. Conductivity will decrease. Now again add 0.5 ml. Again this reaction will happen. Again some of the H plus will be converted into water. Again you add 0.5 ml. Again some HCl will be converted into water. Again you add an NaOH. So 0.5 ml each, 0.5 ml each you have to add. So each time the amount of concentration of H plus ion will be reduced. Conductivity will reduce. Am I right? Any doubt about it? Any doubt about it?
No, sir.
No,
No.
sir.
Now, at a particular point, the entire HCl will be converted into sodium chloride and water. No HCl will be present at a particular time. The entire H plus will be consumed at a particular addition. Am I right?
Yes, sir.
Because initially H plus were more. You are adding sodium hydroxide, H plus concentration came down. At a particular point, the entire H plus ions will be consumed. And we call that point as neutralization point. Am I right? Neutralization point. Right?
Yes, sir.
Yes, sir.
So neutralization point is the point where there is no HCl and there is no NaOH. Because the entire HCl and NaOH are converted into sodium chloride and water. No doubt about it. Clear? Right?
Yes, sir.
Yes, sir.
So that is the point where the conductivity will be minimum. Right? It will reach minimum conductivity.
Yes, sir.
Now, But you are not stopping the addition of sodium hydroxide. We are adding again sodium hydroxide. But if you are adding again sodium hydroxide, whether there will be any reaction after this neutralization point. If you are adding again sodium hydroxide, whether there will be any reaction happening. Any reaction will happen after that?
No,
No,
sir.
No, sir.
No, because all HCl were consumed. Now, if you are adding NaOH, NaOH will dissolve in that water and will become ionized. Only that will happen. No reaction will happen. So no reaction will be happening after the neutralization point, because if you are keep on adding sodium hydroxide, there are no HCl to react with the NaOH. So whatever NaOH you are adding after the equivalence, after the neutralization point, we will call the same point as equivalence point. After that, when you add sodium hydroxide, that sodium hydroxide will dissolve in water. But we know that when sodium hydroxide dissolves in water, it becomes Na plus and OH minus, right?
Yes, sir.
That means you are introducing a new ion, which is OH minus. Am I right?
Yes, sir.
So you are introducing a new ion. What will happen to the conductivity? Increases. Because you are adding a new ion. Now this new ion will take the conductivity. Am I right? So you can ask a question, sir. We were adding sodium hydroxide initially. Then at that time, why this OH minus ion didn't increase the conductivity? Reason, at that time, these OH minus ions were not formed. These OH minus ions took this H plus and formed water. So OH minus ions from the sodium hydroxide, was it available for conductivity before the neutralization point? Was it available? No.
No, sir.
We were adding
No,
sodium
sir.
hydroxide. Question is, we were adding sodium hydroxide, but that OH minus ion actually reacted with H plus and formed water. So till neutralization point, whatever sodium hydroxide we were adding, that OH minus ions got consumed. It was not available. But now, after the equivalence point, there is no reaction happening. Whatever sodium hydroxide you are adding to the solution, it will increase the concentration of OH minus ions in the solution. And this OH minus ions will improve the conductivity. So if I draw a graph, I will get like this. Am I right? I am measuring conductivity, specific conductance. Unit will be Simon per meter or millisiemens per millimeter. Any unit you can use. Volume of NaOH. Before adding NaOH, the solution was HCl, and we know that HCl contains so much H plus ion. That's why its conductivity is the highest. Am I right?
Yes, sir.
Yes, sir.
When you add 0.5 ml, conductivity decreases. Again, you add 0.5 ml, conductivity decreases. Reason? Highly mobile H plus ions were replaced by less mobile Na plus ion, right? H plus ions concentration decreases. That's why the conductivity decrease, and neutralization happened, right? Now there is no HCl present in the solution. At this point, no NaOH is present. Whatever HCl and NaOH that you mixed completely reacted to form sodium chloride and water. This is the equivalence point. Got my point? Any doubt? But are you stopping the addition of sodium hydroxide? No, you are keep on adding 0.5 ml each, 0.5 ml each. Now you are keep on increasing the concentration of OH minus ions in the solution, which increases the conductivity. Understood the graph? Understood the graph?
Yes, sir.
Yes,
Right? Now,
Sir.
see the dot, the mark, the points. There is a decreasing trend, then there is an increasing trend. Am I right? There is a decreasing trend and there is an increasing trend, right? So I have to draw a straight line through decreasing trend and increasing trend, and the graph looks like this. Am I right? a straight line through the decreasing trend, a straight line through the increasing trend. Both the line meet at a particular point. From that particular point, I draw a perpendicular to the volume of NaOH axis. So I got a point here. This much volume of NaOH is the equivalence point. Any doubt in this? The graph drawing, any doubt?
No, sir.
So what is this equivalence point? Equivalence point is, it is the volume of NaOH required to neutralize the HCl. Am I right? Because equivalence point is neutralization point. So equivalence point volume means it is the volume of NaOH required to neutralize HCl. Am I right? Right?
Yes, sir.
No doubt. Right? Our experiment finished. Our experiment finished. Now we have to use this equivalence point for our calculation. Calculation is very simple. N1 V1 equal to N2 V2. Normality of HCl into volume of HCl equal to normality of NaOH into volume of NaOH. If our job is to find the concentration of HCl. Our job is to find the concentration of HCl, which is NHCl. So equation will be normality of NaOH. I told you, I have given you NaOH with a known concentration. In lab, I will give you 0.4 normal sodium hydroxide solution. So this value is known to you now, 0.4. Clear? Understood? 0.4.
Yes.
When you start your experiment in the lab, I will give you that value into volume of NaOH. This is the equivalence point. So from here to here, how much volume of sodium hydroxide? So from the graph, from the equivalence point, you will get volume of NaOH. So that is known to you, right?
Yes, sir.
Divided by volume of HCl. You only took HCl in the beaker, right? So you know the volume, 25 ml. I told you, 25 ml. So all these three values are known to you now. Normality of NaOH, I have given you 0.4. Volume of NaOH, you calculated from the graph. Volume of HCl, you only took HCl as 25 ml and you put it in the beaker, right? So all these three values are known to you. Do the calculation, you will get HCl concentration in normality. Clear? Any doubt?
No, sir.
Once you got the concentration in normality, if you want to convert that concentration into grams per liter, sometimes we will use the concentration time grams per liter. How to perform? Very easy. Normality value, how much you got, multiply with the gram equivalent weight, right? Gram equivalent mass. You studied in your plus one. HCl gram equivalent weight is 36.5. How? H1 Cl 35.5. So 1 plus 35.5, 36.5, right?
Yes, sir.
Yes, sir.
So whatever
Yes, sir.
NHCl value we are getting here, we have to multiply with the 36.5. That value will be the concentration of the given acid in grams per liter. So my explanation or the theory, the calculation behind that experiment, it got over. Now, if you have any doubt related to this experiment, you can ask. Still, I have not answered one question: how you will measure length and area of a solution. Am I right?
Yes, sir.
Yes,
Simple.
sir.
You will go to the instrumentation. Now you see, we are actually measuring the conductivity of the solution trapped between the electrode. Am I right? So length of the solution means distance between these two electrodes. Distance between these two electrodes are length. Okay.
Okay, sir.
Area of these electrodes are area of the solution. Now you got, right?
Yes, sir.
So with the help of conductivity cell, we are actually giving that L by A value. Length and A is actually the length between the electrodes and area of the electrodes. It's exactly the same as that of the length of the solution and area of the solution. Now you know how you will measure L and A. You don't need. Clear? Any doubt?
No,
Any
sir.
doubt? If you have any doubt related to this experiment, you can ask me. Now, until you come to lab, I will not be able to assess your performance in the lab. But there is a session in the experiment that is Viva. So normally Viva will be conducted like this. If you are doing an experiment in the lab today, you are doing the experiment today, then next Friday you have to give Viva. So we will ask you questions, around 7 to 8 questions we will be asking based on the experiment that you performed in the last week. Then based on that, we will give marks. Now that real Viva that is that happens in the laboratory, that will not happen. So what I'm planning, I will explain the theory behind all this experiment, and I will show you a video how that experiment will be conducted. You have to listen that. Then I will provide the video in WhatsApp also. Then you have to read. I will share the PPT also. You have to read. You have to listen that video. Based on that, I will be asking questions. So when you complete 2 experiments, when I will discuss 2 experiments next week. So it will be next Friday, I will teach you 1 more experiment. Then next Friday, I will take 1 experiment. The remaining time I will be utilized for taking Viva. So I will give you the list of the students and timings, which time they have to be online for the Viva. Okay. So I will ask questions based on that. You don't worry, I will even give question bank. I will even give you question bank. So each experiment, minimum 10 to 12 questions I will give you. You have to find the answer and be prepared for that. That's it. Okay. So if you know all those 12 questions, you will be able to answer most of the questions that I ask. So it is not a big issue. You have to read what are the questions. Now, there will be a laboratory manual that I will send you tomorrow. Tomorrow I will send the PDF of the laboratory manual that you can keep it in your mobile, or if you want to take a printout, you can take it. The theory, whatever I explained, not this much, but small amount of explanation is there in the laboratory manual also, and how the value should be ended. Those things are also mentioned in the laboratory manual. Once you read that, you will understand this. I hope you understood this experiment. If you have any doubt, you can ask me. If you don't have any doubt, I will play the video where how to perform the experiment that I will play you. That I will play. If you have any questions, you can ask. Any question? Any questions related to conductivity? This experiment?
No, sir.
No doubt. Okay, then I will play the video. So it's Dr. Sunil. He was my colleague. Now he's not part of Ramaya. So he already did 1 experiment. I will send you a video with a high quality, because you will not be able to perfectly see, because if your internet is slow, then you will not, there will be some issue. Don't worry if you are not listening it properly. Don't worry, after the class I will send you the video. Now I will play. I will play for 10 seconds and you check whether sound is coming or not. Okay. Okay, I'm playing it now. So is it audible, the video?
No,
No,
sir.
sir.
No,
No, sir.
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 No,
it's not
sir.
audible, right? Okay, then what I will do, I will stop it here. Within 5 minutes, I will send you the video. Okay.
Okay, sir.
So
Yes, sir.
Okay.
you listen that video. I will put it in WhatsApp. Let me see whether I can put it in Teams also, because the size, if it is more, maybe it won't come in Teams, but definitely I will put it in WhatsApp. Okay. Then if you have any doubt, you can contact me personally, no issue. If you have issues like you don't have the confidence or something in the class, if you are afraid to ask question, don't worry, you can ask me personally. You can give me a call. My phone number is there in WhatsApp, right? You can get that number. You can call me, preferably evening, because I will not be having class at that time. Or you can send me questions through WhatsApp within half an hour or 1 hour. Definitely, I will reply. Okay.
Okay, sir.
Okay.
Yes, sir.
Aryan is in this class, right?
Yes, sir. Which one? There are two.
No, any Aryan will work.
Yeah.
Okay. I have shared you notes, right? My personal notes
The first two chapters,
sir.
yes, sir.
for electrochemistry and
Fuel cells and batteries.
yes,
And fuel cells.
You can share it with your friends, okay? This new students. Even though I'm not taking theory part, you can share that, okay?
Yes.
You put it in the
Okay, sir.
group. It will be helpful for them, okay?
Yes, sir.
So the students who are already got those kind of notes, please share it with in your batch, right? Not to other batch, in your batch, CSE, okay?
Yes, sir.
Okay then. Thank you. So
Thank
I will
you,
send
sir.
the video in
Thank you,
10
Thank you, sir.
It will take to upload.
Thank you, sir. Thank you.
So if you have any doubt, you can text me. Okay, fine. Thank you.
Thank you,
One
sir.
second, one second. I will take the attendance. Let me download the attendance. Okay, thank you.
Thank you, sir.
Thank you,
Thank
sir.
you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
sir.